Let's say I have two different classes and I graphed their data. Now keep in mind you would need a class with a large enough sample size in order to approximate that bell curve trend. If you only have 30 people in a class, it's probably not necessarily going to look like that bell curve, but it could. I can figure out based on my graphs where the mean or the class average is for each. I can also determine what the standard deviation is for each. But if I want to compare those two classes, it's not enough just to say this class has the higher class average. I also need to take that standard deviation into account to look at that spread of data. That's where something called a z-score can come into play. A z-score is a way that we can compare data from different bell curves to that standard normal distribution. We call it a z-score because normal distribution, that bell curve, is sometimes referred to as z distribution. If I calculate a z-score for a particular data value, so let's say, for example, your math mark, that z-score is going to tell me, are we above the mean or are we below the mean? It's also going to tell me how many standard deviations we are above or below. In order to easily compare that data, we're going to set the mean to 0 and we're going to set the standard deviation to 1 when we use z-scores. In this question, we've gathered data from a credit card company, and they recorded how long does it take in days for an adult to receive their credit card after they approved. They tell us that the data is normally distributed, and they also give us the mean. So we know we're going to set up our bell curve, and we're going to put the mean in the middle, and we're going to box it so it clearly stands out. They also told us with that data, there's a standard deviation of 2. So above the mean, I'm going to add 2, add 2, add 2. Below the mean, I'm going to subtract 2, subtract 2, subtract 2. So I'm going to take a particular data value, and we're going to start with 18. So 18 is right here. So 18 days was how long it took these people to get their credit card. I can see that this is above the mean. I can also see that it's 2 standard deviations above. So I'm going to tell you that it is above the mean. It is 2 standard deviations above, and that means we have a z-score of 2. If it took 8 days for your credit card to arrive, we can see that 8 days is a lot faster than the mean. So we are below the mean by 1, 2, 3 standard deviations. So 3 standard deviations below the mean, I'm going to tell you that means our z-score is -3. You pause the video and I want you to fill in the last 3 rows in that chart. In our third row, 14 is the mean. That means we're neither above nor below. We are no standard deviations away from the mean, so that means our z-score is 0. We're right on the mean. You should have also noticed that every time we are above the mean, we have a positive z-score. Every time we are below the mean, we have a negative z-score. So once I calculate the z-score, that instantly tells me, am I above the average or am I below the average? The higher the z-score, the further we are from the average. The lower the z-score, the further we are below that average. If you write a quiz and I give you your mark, that tells you how many questions did you get right on that quiz. If I give you a z-score, that's going to tell you how did you do compared to everyone else in the class. In this particular case, we give z-scores instead of marks. We know that z-scores are standardized to the table with a mean of 0, and each standard deviation is 1 unit either above or below that mean. So if we're going to compare Ashley and Robert, Robert has a z-score of 2.8. So this is a number line. 2.8 is between 2 and 3. So if you imagine this broken into 10 intervals, 2.5 is in the middle, 2.8 is going to be somewhere over here. Ashley has a z-score of 1.2. 1.2 is between 1 and 2. 1.5 is in the middle. She's going to be somewhere right here. So we can see because these two z-scores are positive, they are both above the class average. But because Robert has a higher z-score than Ashley, we know that Robert did better than Ashley did. And keeping in mind what we know about the bell curve, this is 50% of the class. This is another 34% of the class. So you can see that Ashley has done better than over 84% of her peers. And then Robert, remember, this is only 0.15%. This is 2.5%, and Robert's clearly over here a little bit more. So Robert has done better than about 99% of his classmates. Now, in this example, we gave you their two z-scores. You're going to now calculate a z-score. This is the z-score formula that we can use to calculate a z-score. We already recognize this is the mean and this is the standard deviation. Now, a lot of these skills are going to be incorporated into one question. So you need to put all of these pieces together. You know on your calculator, given a set of data, how to find that mean and standard deviation. You may have to start by doing that. And then you're going to take your particular data value, so your particular mark, your particular whatever it is you're looking at, and you're going to figure out how far is it from the mean, and then you're going to divide that by the standard deviation. Remember, you have to press enter before you divide or put this in brackets to calculate that whole numerator value. Okay, so I'm going to give you 3 pieces of data and you're going to practice. I want you to calculate the z-score. Z-score of 4 tells me that on a bell curve, I'm way on the higher end of those values, beyond 3 standard deviations above. My second one, because it's a negative, that tells me I'm going below the mean and I'm less than 1 standard deviation below the mean. Always, 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 if you get an irrational number, you have to round to 2 decimal places. To the nearest hundredth, rounding rules apply. So you have to follow those rounding rules and round properly, because we're going to start looking at how you use a z-score table, and we have to get these numbers rounded correctly to the nearest hundredth. We're going to look at 2 examples of how you can apply this. In the first question, we're given a table of data, and it represents Tony's midterm marks for both math and physics. Now, we can clearly see that Tony did better in math than he did in physics. We also know the class did better in math than they did in physics. The question, however, wants to know in which subject does Tony perform better relative to the rest of the class. So it's not just here's the higher mark or here's the class average. If we're comparing relative to how everyone else did, we also have to take that standard deviation into account. I need to calculate the z-score so that I'm able to compare the data from these 2 different classes. I'm going to get you to pause the video. I want you to practice calculating each value, and then you come up with the final conclusion. In which subject does he do better relative to the rest of the class? Calculating the z-score for both math and physics allows us to standardize that data to a bell curve. So now if we put the mean as 0, we can see that in both cases, because these are positive, Tony is going to do better than the class average. So there's not much difference. 0.17 is going to be about almost 2/10 over, and 0.27 is, again, just barely over 2/10 over. So we can see, compared to the rest of the class, he did slightly better in physics than he did in math. The other thing you have to watch is you cannot leave your z-scores like this. We always round them to the nearest hundredth. Follow your rounding rules. The next digit is a 6, which bumps that to a 7. The next digit is a 2, which means that stays as a 7. And in our final example, we're given the mass of different cantaloupes, and we're told that the cantaloupes have masses that are normally distributed. They give us the mean, and we are ultimately looking to calculate the standard deviation. You only have one formula for this unit, and it is on your formula sheet, by the way, so you don't need to memorize this, you just have to be able to use it. We know standard deviation is sigma, so I'm looking for that value there, which means they have to give us 3 other pieces of information. So I would start by just making a list, read through the question carefully, and see if you can fill in what those values are, and then I want you to substitute them into the formula and algebraically solve for your standard deviation. Our particular cantaloupe has a mass of 1.7 kilograms. So the first thing you should have noticed is that's our X value. They tell us the mean is 2.3 kilograms. And again, you have to watch the units. They do all have to be in the same unit. They are in this case. And then it also tells us that we are 1.01 standard deviations away from the mean. We know the number of standard deviations away from the mean is our z-score. Where you have to be careful is that it tells you that we are below the mean. That indicates our z-score is negative. So it's not going to say that necessarily in the question. You have to know below the mean means we have a negative z-score. When I substitute that in for the place of the z-score, because I'm ultimately looking for sigma, I want to get my variable off the denominator. So I'm going to multiply to get that canceled out, and then I'm going to multiply the same thing over here. So we have negative 1.01 sigma equals 1.7 minus 2.3. All right, so carry on, simplify that, and get the value of the standard deviation. Because the question tells us to round to the nearest hundredth, Hundredth, remember, is 2 decimal places. So look at the number that comes after. If this number is less than 5, this stays the same. But if this were 5 or greater, remember, you'd have to go up. In this case, we don't need to round up. Our standard deviation is 0.59. And then verify that. If you substitute that back into the formula, check, do we get negative 1.01 as our answer? Now keep in mind this is rounded, so you may not get exactly 1.01. You'd have to put this entire answer into your calculator to get that value, but it should be close. So anytime we have data from different data sets, standardize them to one bell curve, mean of 0, standard deviation of 1, get those Z-scores, and then we can compare the data relative to each other.